Okay, so today we're going to look at just the vertical stretch, vertical compress. This is what's considered a dilation. Okay, and we'll define that once we get to that definition in the notes. But last time we talked about the C, the D, up, down, left, right. What kind of transformation was that called? A translation. Okay? Translation was up, down, left, and right. Today we're going to look at dilations, which is stretch, compress. So again, up at the very top, that g of x, that is your transformational function, where the a value is positioned in terms of the function f. Okay, and is the a value inside or outside the function here? It is outside. Okay. So based on the position of the a value, do you think it will affect the x or the y values? Kind of think back, whenever we talked about transformations early in the year, I referenced the Stranger Things, where everything inside affected either the x or the y, and outside affected the other. Be the y. Okay, so your a value, so to go over that again, your a value and your d value, everything outside the parentheses, that is going to affect your y values. Now, right underneath that, let's go ahead and write this, because this is what it'll look like if it is quadratic and not in that transformational form. Below that it says, let's consider various a values to understand the effects on the basic function f of x equals x squared, so the parent quadratic function. So what I want you to do is first grab your calculator, and in y1, I want you to put x squared, and then y2, I want you to put 2x squared, y3, 3x squared, y4, 4x squared, and compare all the graphs that get graphed after the first one, because the first one it's going to do is the parent function. Alright, so whenever you do this, it's going to look like, please pay attention, it is going to look like it's getting skinnier. Okay, that's probably the most common word that's been used. So it's going to look like the edges of the parabola are kind of coming in together because we've taken it and we've vertically stretched it. Alright, so if I take how you would do this if you were asked to graph it, alright, first you need to make sure that you're good on these reference points, and we'll talk about these real quick. For your parent quadratic, those are going to be your reference points. So anytime you're given an assignment that you know is going to have transformations, maybe like a quiz or a test, I would write that. That's the thing that I would write right whenever I got the quiz. Okay, and then you would apply transformations to those points. So we said that the a value, is it going to affect the x or the y? The y. So let's just go off of this first one, 2x squared. What would I do to all of my y values? Someone take a guess. Nope. Do what? I'm going to multiply all of my y values by 2. So 0 times 2 is 0, 1 times 2, 4 times 2, 9 times 2. Once you have that written down, go ahead and do B the same way. I want you to do y2. Keep y1 as x squared. y2, do 1/4 x squared. y3, 1/2 x squared. y4, 3/4 x squared. Okay, so most people, that is the term that they would use. Okay, it's getting wider. Alright, so it almost looks like The arms of the parabola are getting stretched out that way, but it's actually, I don't want you to think vertically, it's being compressed towards the x-axis. Okay, vertically. So it's the same idea as this table that we just made. The only difference is now, what do I need to do to all my y values? If we were looking at, let's do 1/2. If we were looking at that one, what would I need to do to all of the y values from the parent function? No, don't multiply by 2. That told us to multiply it by 2. Oh, divide by 2. Okay. You can either divide by 2 or you can multiply by 1/2. Those are doing the same thing. If you want to be consistent with the rules, no matter what that a value is, then you would multiply by 1/2. Okay? And so that would give you 0.5, 1, 1.5. Sorry, that is absolutely not right. I was looking at the x values. You'd have 0.5, 2, and 4.5. Once you have that written, go ahead and go to the next part on there. Okay, skipping C, looking at D, it says, does the A affect the x values or y values? Which we already said that it affects the what? Y values. In that paragraph, whether you're highlighting, underlining, whatever, there's a few definitions in here you need to be good on. A vertical dilation. That is a type of transformation that stretches or compresses an entire figure or graph. In a vertical dilation, notice that the y-coordinate of every point on the graph of a function is multiplied by the a value. You can also think about this as either a vertical stretch or compress. Vertical stretch is the stretching of a graph away from the x-axis. Vertical compression is compressing it towards the x-axis. 3 says, is a dilation the type of transformation that preserves both the size and shape of the function? So, does the parabola keep the same shape if we stretch it or compress it? No. All right, and then if you want, and we talked about this just a little bit, it is not a rigid transformation. We said that word last time. A rigid transformation is one that does keep the size and shape. So that is left, right, up, down, and any kind of reflection. Go to this question mark right here. This is a good point because I see this mistake a lot. It says, Dan says that the graph, consider the function 3 over 2 times x squared. Dan says that the graph of the function will look more compressed than the parent function because the a value is a fraction. Jeannie says that the graph of this function will look more stretched because the a value is greater than 1. So who is correct? Jeannie. And the reason is because 3 over 2 is greater than 1. The rule does not say that it vertically compresses because the a value is a fraction. It vertically compresses because it's between 0 and 1. A fraction can be greater than 1. Very easy. And down at the very bottom, this just sums up the stretch compress. So vertical stretch, if it's greater than 1. Vertical compress, if it's between 0 and 1. Okay, so going to these. So now we're going to deal with the negative. What does that negative do? Reflect over the x-axis. So on this one, instead of plugging all these in, and I actually think this may take a little less time, which I'm sure you're okay with. Again, if these are my parent functions, 1, 2, 0, 1, 2, 3, 0, 1, 4, 9. Let's just do negative 3x squared. So that means I'm going to take all of my y values and do what to them? I'm going to do what? Alan, what am I going to do? Well, but if that's my a value, what am I going to do with all my y values and negative 3? Philip helps up. Multiply by negative 3. Okay, and that operation, that will flip them whenever we graph the points. So I have 0, all my x values are the same, 0, 1, 2, 3, and then I've got 0, negative 3, negative 12. I can probably stop there because I already won't be able to graph negative 12. So I'm going to start to graph those points. I've got 0, 0 still. I've got 1, negative 3. And I've got 2, negative 12. So we'll say roughly right there. All right, now, what part of the parabola, and again we talked about this I think last class, what part of the parabola do I use to get this other part of the parabola? The line of symmetry, or axis of symmetry. Okay, so my axis of symmetry on this one is still right there, and now I'm just going to reflect those points across. And it looks a little bit skinnier than that parent function. All right, so down here it's the same. It's the exact same idea. We're not going to go through it. It's the exact same idea, just with a fraction, though. Okay, and it doesn't change the stretch or compress. It's just reflected, which is what question C says down there. Or it's what it's asking for. How did the a, whenever a is less than 0, how did it affect the graph? Reflects across the x-axis. Okay. Right here it says, identify the line of reflection for each graph in question 6. So, do not get line of reflection confused with axis of symmetry or line of symmetry. The line of reflection, it is the x-axis, or y equals 0. Okay, that's whenever we say that it reflects across, we always say reflects across the x-axis, because the x-axis is the line of reflection. This down here is just a nice typed out, condensed summary of all the transformations we just talked about. So coming down here, if we have any point on a graph and we have these transformations that exist somewhere in an equation, A, C, and D, what two transformations are going to affect the y value? The A and what? There is no B in there. There's A, C, and D. D. I'm going to multiply the A times the Y, and then I'm going to add the D. It's going to, and then what's going to affect the X value? The C. If it's minus C in the equation, what am I going to do to all my X values? I'm going to add whatever number that is in the equation. Get that written down, go ahead and flip it over. I'm going to skip that part right there because I don't like it. So go find this spot right here where you start to see it's green on your paper, it's blue up here. Okay, so this has a certain equation that's up there at the very top, negative x squared minus 3. And it says that these three people, they use different strategies to provide the step-by-step reasoning by each student. So, this first person right here, step 1, they start by graphing the parent function. Okay, and this is going to seem weird, but I'll sum it up once we get through these three problems here. The next thing this person does, step 2, is right here. He reflects it across the x-axis. You can just put reflect if you want. The last thing this person did is they moved it down 3. Coming down here to Julia, first thing this person did, again, was to graph the parent function. But then the next thing this person did is they moved it down 3 units. And the last thing they did was reflect it. Once you get that written down, turn that over. There's one more example of these. We'll fill it in. I'll have to kind of explain. I'll have to kind of explain this one. This is, now, just so you know, this is the person that overthinks the problem and is kind of weird and makes it harder on themselves than they have to. Okay?
It's my name.
Oh, well, no, that's bad. So what this person did, so look below, the original graph was this, original equation. But if you look up there, the first thing what they did is they rewrote it, and they pulled a negative out and made it this right here. Okay? So, the first thing that this person would do, and I don't agree with the steps that's on here, so we're going to add step. First thing that this person would need to do is to always start with the parent function. Okay, that's where you always start off at. Now, after that, if I just graphed that right there, okay, so let's say there's no negatives, there's no parentheses, I just gave you this. This transformation, which direction would this take it? Up 3. So the next thing they did, they just took the parent function and they moved it up 3. The next thing they did is they dealt with the negative, which the negative does what? It reflects it over the x-axis. So the point of all this is, as long as you're doing each individual transformation correct, the order in which you do them does not matter. Now, looking at this, you have got to be careful whenever you have something like this, because a lot of people, they'll get to this step, if they were to do it this way, and then if I asked them to reflect it, I would get a whole lot of this. All right, but you got to remember, We already stated that the x-axis, that is the line of reflection. So if the vertex is 3 units from that line of reflection, then whenever I reflect it, it still needs to be 3 units from the line of reflection. Okay. Go ahead and go to this part right here. So this is a little bit of a summary. We'll get to actually doing it on the back, which I kind of like the math more than the graphing here. So it gives us this equation of 2 times x minus 3 squared plus 4. So if you remember last time whenever we talked about moving this around, we would take the vertex and we would move it first. Then we would apply the transformations to get the other half, the rest of that half of the parabola. Use your axis of symmetry to get the points that reflect across. Okay. So on the back of this is where it kind of breaks it down. So if I'm looking at this, L, what am I going to do to all of my x values on this one? I'm going to do what? Do what? Add 3. So what am I going to do to all my y values? So is that add 4 or subtract 4?
Yeah, add 4.
Add 4, what else do I need to do? So we've got this one, we've got this one. What is that going to do? So what?
By 2.
So am I going to add, subtract, multiply, or divide by 2? Multiply the y's by 2. Alright, so I'm just going to go in, all my x values. I'm going to add 3 to all those. All my y values, I'm going to multiply by 2 and then add 4. Okay, so that's just kind of the process to getting those points. You're always going to go off of those reference points from the basic quadratic function. On this problem right here, all it is saying is that we are now going to replace the a value with 1/2. Everything else is going to be the same. So it's still minus 3 and plus 4. So if my a value is 1/2, what is that transformation going to be considered? Vertical what? Compression. So everything is the same here except for the a. So I'm still going to add 3 to my x's. I'm going to add 4 to my y's, but what else do I need to do to the y values? Do what?
Divide by.
No, multiply by 1/2. I want you and the people at your table to apply those transformations and then graph it down there at the bottom.
Right. And then the last one's today. We're uninvited persons. It's not because you are No, it's blue. It's just. I'm not dressed as school. Don't look at the first. Check out doing the parent function. Huh?
Yeah, no, we do tomorrow, because yesterday,
Oh,
we had it for first period.
Put the line down the,
Yeah, we're not gonna finish it. We only want that first. I was excited.
okay, and then you have to like, take that line and then put it all the other line. She did.
A lot of times, especially if it's going to be vertically compressed, I can use, and normally I'll use it anyways, it's that 3/9 point. Okay, so on this one, that's going to give me 6. Half of 9 is 4.5. Plus 4 is going to give me 8.5. That's just going to give me one more reference point. And it's going to give me a graph that is going to be a little more accurate than I would have had. Okay, and on this specific one, we probably could have used 4 and 16 as well. That would have been the next one. So the parabola that you should have gotten looks like that. So now going here, in this next example, they're saying use the exact same thing, but now the A value is going to be -2. So what is going to be different about this transformation? Okay, it's going to be vertically stretched compared to the last one. It is also going to reflect.
Why don't you use this word?
No, like, negative, not I remember learning, like, that kind of stuff, and, like, my teacher would be like, I'll remember that, and I still was like, what the heck? I still don't, honestly, remember these. Like, we had, like, -4 plus.
Yeah, like, why can't they just keep doing it? When we added negative, that's just like, no, we just like, what happened? You can't have a negative.
Yeah, you can. That's called dead. Okay, wow. Whatever you say. Don't be sassy today.
And you were such a good have dead. You could open, yeah.
Okay, so if I'm graphing this, and this is without all the nice little neat charts that they have so you can organize it, because you won't be given that on the test. Okay, so I would have those written out somewhere. If this is my equation, what am I going to do to each x value?
+1.
I'm going to add 1. So I've got 1, 2, 3, and 4. What am I going to do to each y value?
Divide by half and plus 2.
Do not divide by 1/2, divide by 2, or multiply by 1/2, and then add 3. So I've got 3. Half of 1 is 0.5, plus 3 is 3.5. Half of 4 is 2. 2 plus 3 is 5. Half of 9 is 4.5. Plus 3 is 7.5. Real quick, everybody look up here because I meant to do it on the previous problem and forgot. 0, 0. That is the vertex of the parent function, correct? Everybody agrees with that? The point that I get from 0, 0 after I apply the transformations, is that always going to be my new vertex? Yes, always. So make sure that you know that that is your starting point. We've got 1, 3. I'm just graphing the rest of this out. So these two are a little different because it says, here's the graph, what's the equation? Everything we've done up to this point says, here's the equation, graph it. Alright, now there's a couple things that are really easy to figure out, like the left, right, up, down, and the reflection. Now if I'm writing this equation from a graph, I'm always going to do vertex form, because it's, in my mind, it's the easiest. So looking at the graph, now there's not a lot of room up here, but the parent function would roughly be right there. And now here's my new vertex at 1, 0. So did it go to the right or to the left? Right. Is that plus or minus? How many units? Did it go up or down? No. The vertex went to the right 1 unit and that's it. Did it reflect? So what do I need? Okay, so that's all the easy part as far as writing the equation. The a value is what throws people off. Okay, so follow me here. If I go from the vertex of the graph, not the parent function, and I go to the right 1 unit, and then I go down until I hit the parabola, how many units down did I go? That's my a value, 2. It's almost like you're finding a slope for 1 unit. It's not a slope though. Parabolas do not have slope. But you're just kind of finding it for that part right there. Okay, for 1 unit over from the vertex. So if I go to B over here, again, I'm going to start off with this right here. If you need to roughly sketch that for reference, it's never a bad idea. So, did it move to the left or to the right? Is it plus or minus? How many?
2.
Up or down? How many?
5.
Okay. Does anybody know what the a value would be? 3. Okay. Now, if I go to the right 1 unit, I'm not going to go down because it didn't reflect. I went down here because it reflected. I'm going to go whichever way the parabola is. So from there I would go up. Okay, I went up 3 units before I hit the parabola. So that a value is 3. I had someone last class, do I have to go to the right 1 unit? Or do I have to go to the right? You don't have to. I mean, if you go to the left, it's always going to be the same though, because it's symmetric. We're going to skip that.